Okay, so let me start this discussion workshop. So welcome everyone. This workshop is entitled as Discussion Workshop on AI cross physics, cross philosophy. And today I have honorable guest, Professor Michael Finkenthal from Johns Hopkins University, who will deliver some thought on philosophy cross physics in the era of AI. And after that, it will be followed by Professor Suzuki's talk, who is now in International Institute for Advanced Studies, and her profession is on philosophy and AI. And then finally, we have a discussant and speaker, Professor Jun Otsuka from Kyoto University, Faculty of Letters, who will talk about his viewpoint on philosophy in the era of AI. And now, as you see, this is a quite interdisciplinary workshop. And I'm afraid if our even language cannot be transmitted even among four of us, but we hope that we can communicate and also we can reach to some point, some good conclusion after the discussions. So discussions among these speakers, and also if physicists and philosophers are in the audience, it's quite encouraged. And from Zoom, please ask the question after each talk. But for speakers here, I'd like to ask you to make questions even during the speech. Okay? So Professor Finkenthal, Professor Otsuka, and Professor Suzuki, if you have any question during the talk, please keep the question. Okay, so today's topic is AI, physics, and philosophy, and we four of us have very different viewpoints on this subject. And so from each of us, we start giving each viewpoint. I'll give 20 minutes talk from now, and after that, Professor Finkenthal will give 40 minutes talk, and we have a break. And then after that, Professor Suzuki will deliver us 20-minute talk, and Professor Otsuka gives us the final 20-minute talk. So in this way, we four of us provide four viewpoints, and hopefully after some discussions, we can come to a common understanding of the field and also how this interdisciplinary field can develop in the future. So one thing I have to emphasize is that, so this is the construction of today's workshop. Yes, as I told you, I'll give a 20-minute discussion, and then 40 minutes talk by Professor Finkenthal, and after a break, Professor Suzuki and Professor Otsuka will give a talk. Okay, so let me actually talk a little bit about why we are having this workshop today. So in fact, from last year, this is a continuation of some discussion seminar series, which started actually last year, and this is I think fourth one. And in the previous three times, physicists invite philosophers to have a discussion on how we actually develop our science in the era of AI. So we need a hint from philosophers, since it's a gigantic technical wave coming from this AI world to physics, and we are at a loss, kind of. And so we need to ask philosophers to see the future. So that was the starting point of the discussion last year. And through these three discussions, last year and this year, we have very good discussions, but we are still at a loss, in the sense that we cannot foresee the future, even in the span of 1 or 2 years. So today, we get together again and to listen to each talk from very different viewpoint. We remind ourselves how we did discussions in the past series, and then we need to learn more from, for example, Professor Finkenthal's viewpoint. Okay, so I consumed already 6-7 minutes. So let me go to my talk in the remaining 13 minutes. So yes. So today I'm gonna give you two views. This is it. The first commitment of mine is this statement: MLPhys is a new paradigm, not following Thomas Kuhn's new famous method of classification of revolutions in scientific activities. And the second point is, in fact, a continuation of what we discussed in the past 3 series of these seminars. It's about how to draw a map of MLPhys. MLPhys is an abbreviation of machine learning physics, which is the name of this grant funded by the government about the research activities which unites AI and physics. And I'm a director of this initiative that is abbreviated as MLPhys, as in my t-shirt here. And this MLPhys is a big group of 60 researchers in Japan, and it's only for 5 years, but we are in the 3rd year in the course of the total 5-year grant. And we are producing really interesting results in physics research using AIs. And we are actually demanded to create any kinds of map which could be useful for young scientists who want to come to this field in the future. And that is the purpose of creating a map, but we don't know what kind of map we need to create, or what is the map itself. And we had a good discussions last time on this definition of the map, and I'd like to tell a little bit about that. Okay, let me start with the first one. AI physics is a new paradigm, apparently. However, it's not following the theory of Thomas Kuhn. So let me make a brief review of what Thomas Kuhn wrote in his famous book entitled Structure of a Scientific Revolution. So he says in this famous book that when some unexplainable phenomenon is found in science, then scientific community will lead to 3 possibilities: A, B, or C. So what is A? This unexplainable phenomenon is in fact explainable in the realm of the ordinary science, and then it's resolved. So paradigm doesn't change, and paradigm actually just continue. So this is a possibility A. And possibility B is that although it's not explained in the paradigm, it's just kept untouched. So it's postponed. And this is also possible, since if the paradigm, the scientific activity, has a very big momentum, then it does not actually be, it will not be corrected by this outer unexplainable findings. So B is possible, but the important for us is C, the new paradigm which emerges. This says that this new framework replaces the old, leading to a paradigm shift. And I think many of us agrees that in the research field of AI, in fact, this paradigm shift has occurred in these 10 years, and then the whole community is replaced by the new community. But what about physics? I'm going to discuss that. So history tells us that, for example, the emergence of this quantum mechanics, or even in 17th century, Newton's law, and also special relativity, are the examples of this possibility C. Well, I have to confess that I'm not a philosopher. I don't learn much about philosophy. I just read this book. So I'm just following knowledge from this book. So please correct me anytime, or if you have any opinion on this, please ask me, tell me. And what is the sign of a new paradigm emerging? In fact, this book says that it will appear as a certain phenomena which is occurring in physics community. So one is a proliferation of competing directions, okay? And also discussions on fundamentals and the basis of this scientific realm. And finally, scientists talk to philosophy, yes. So this symptom actually occurs in scientific community, then it's the sign of new paradigm shift, okay? That is what Thomas Kuhn said to us. And in fact, I'm talking to philosophers now, right? So this means that, this is an evidence, right? It's not a coincidental. So it's an evidence that new paradigm emerges in soon, okay? So this is not a joke. In fact, there are many scientists who actually try to refer to philosophic argument to foresee the future. And now, let me argue that, in fact, AI physics will be born through AI shockwave, not in the scheme of Thomas Kuhn, but in a very different way. Okay? So this is my new theory. I'm presenting in front of famous philosophers. It's scary but for me, but let me actually tell you. The exception of Kuhn's theory is, in fact, there is a historic example, which is a quantum information paradigm. So what is a quantum information paradigm? So next year is a quantum year. It's 100th anniversary year from Heisenberg's discovery on quantum mechanics, formulation of quantum mechanics. And now, quantum information scientists are everywhere. They are developing quantum computation, and that's quite interesting. It's technologically advancing right now. So why this paradigm appeared? In fact, this paradigm appeared not because of some unexplainable appeared in nature. It's not because of that, but just because of the computational advance in quantum computation, right? So let me read it. So computational advance in technology reconstruct quantum realm, not by destruction of quantum mechanics. So quantum mechanics is still there. It's a perfect theory. Still, we have a new paradigm. So this is not categorized into any A, B, or C of Thomas Kuhn. Do you agree?
Well, I don't know, but how about the unification of the quantum mechanics and the relativity theory? Isn't it a kind of unsolved problem in physics? Well,
I see.
Completely novice in physics, so I don't know.
I see. Yeah, that's a very good question. So general relativity and quantum mechanics, they need to be united. That's the current paradigm of quantum gravity research. And there is a big challenge, and this will not be categorized as unexplainable, but this is a big challenge, which is set in the current realm.
And can we say that it is kind of, physicists just postponing the solution?
Yes.
Okay.
Yes. So that's B, yes.
Okay.
That's right,
Okay.
yes. So general relativity is B, yes. So here, but what I say is that quantum information is related to this quantum gravity equation, as Professor Otsuka said, but it's kind of different. So quantum information realm is how we can use the new information theory based on quantum mechanics in quantum computer. Okay, so that's a new paradigm since it is everywhere around our physicists. So I think this is an exception of Kuhn's theory, and it will be applied also to AI physics. That's my point. So let me tell you. So in the left-hand side, I have a situation in current AI. There are too much unexplainables. There are too many phenomena which cannot be explained. So there is only empirical law. How do you do that? But it's a compilation of just unexplainables. And now paradigm shift actually occurred. and philosophy is needed. Okay? So this is the current AI. On the other hand, on the right-hand side, we have a situation in current physics. So we have only a few unexplainables. Only a few. For example, against the standard model of elementary particles, neutrino mass is not explained, but it is expected that it will be resolved in the realm of the current quantum physics, not violating the quantum law. So in this sense, there are only a few sudden unexplainables and paradigm shift not occurring now, almost in any fields of physics. I'm from elementary particle physics field, and in particular from that viewpoint, there is no such paradigm shift. So philosophy is in that sense not necessary. No. However, I come to the conclusion. So AI advance will reconstruct the quantum realm. That's my guess. And will lead to a kind of a new field which is called AI physics, in the same way as quantum information. So we don't have an unexplainable. But since AI is a new understanding of nature, in my viewpoint, so it will be forcefully united with the quantum realm in physics. So AI physics will be born, and it will be a new paradigm, but it's not following Kuhn's theory of revolution of scientific activities. Okay, so this is one point. I consumed all of my time. So let me be brief about point 2, drawing a map of machine learning physics. How? So in fact, this is a photo from the last discussion, and the person with white t-shirts pointing aggressively toward the slide is Professor Otsuka. Yes. And he was pointing out that this is not suitable or something. Yes, I don't remember. Maybe slide is too narrow that we cannot see the blackboard. Maybe that's why he was pointing. So anyway, we had a nice discussion about how to create a map. And here is a strategy to create an AI physics map, but let me skip it. So what is the summary of the last discussion? So the point was that when we create a map, then it will lead to a scientific abduction. That was our hope. So once you have a map in your field, then writing your path, how to walk in this map, will lead to some idea of how you conquer this gigantic field, right? And that will lead directly to the abduction. That was our hope. And then there was a good discussion about that. For example, in the map, of course, the name of cities are located, but city is it a scientific notion or a scientific method? So what kind of words we need to put on the map? And map need to time evolve. This is a good comment by Professor Suzuki. And ordinarily, we have a map, but it's a time slice. So at some time you have a map, but time actually needs to evolve. And also, if the map has a white region with no words on it, then okay, that is a place we need to go to conquer this field. But ordinarily, so what you can draw on the map is only what you have already found, right? So this is a kind of contradiction. So maybe a negative result, which was not published in papers, is that this desert, the white place. So that was one point. And in fact, the discussion was concluded with this strong statement: map would be not necessary from the first place. A map is just for newcomers, and we have maps on our brain already, so we don't need it. For example, we can think of this new textbook which we wrote is a map, so that newcomers can actually learn from that. And also, this textbook which we wrote and published this month is with GPT. And this GPT is a map. So you can ask this GPT wherever you want to go. So we don't need to write or draw a map. GPT is just a map. So that's the new point pointed by Professor Sanai. So maybe this is a negative conclusion, but we have a good discussion about that. So today I'm sorry I have 2 minutes over. First, AI physics will emerge as a new paradigm, but not following Kuhn's theory of scientific revolution. And second, as a strategy to live within this new paradigm shift, I thought that we need a map. But maybe we don't need it. We just need to have an occasion like this to talk to philosophers, and then we develop a map inside ourselves, and that's it. Okay, so that was the conclusion last time. Okay, thank you very much. So please. So before getting to Professor Finkenthal's talk, I'd like to have some questions if you have. Yes, Professor Otsuka.
Well, thank you very much for the great talk. So, I have many questions, but just one question. Begin one question. So you said paradigm. Paradigm is notoriously a kind of ambiguous word. There are many criticisms like Kuhn, but there are many characterizations like the paradigms defined by exemplar, and the institution and so on. One thing is kind of the puzzles, a question to be solved in one paradigm. So what do you think are the core questions in your MLPhys new paradigm?
Oh, I see. That's very important question. In fact, I completely agree with that, with you in that paradigm needs to be defined as a puzzle or question, yes. And in my old field, or not old, but so this elementary particle physics paradigm, the ground question is a unification of quantum and relativity, as you said, yes. And this is a puzzle presented. So everyone actually want to solve this ground question. And in any paper in my field, in the introduction, it starts with that puzzle, explaining the puzzle, and my approach is to tackle this very difficult question. I want to resolve this small issue. Yeah. So this is a typical paradigm, right? And in this AI physics paradigm, which is coming, I think no ground question has settled down yet. Yes. So that's why I'm telling my colleagues that this is a ground question from my viewpoint. My viewpoint, if I am allowed to talk to you personally, this is a reconstruction of quantum mechanics. So quantum mechanics is there in the nature, but in AI, we have a theory of training or learning. Right? And training or learning, the theory, that kind of understanding is missing in natural physics. Okay? So we are actually coming to the a very good stage of unifying these AI and physics together. And there are many nice bridges now built. So based on this, I think reinterpretation of this quantum physics in terms of learning theory or something will happen, and that is a grand challenge, I think, yes. But this is quite personal, and it's not common, yeah.
So that sounds like a lot of the kind of the reconstruction of the current theory, not disrupting it, but the kind of keeping the essence itself, keeping it itself, it's just intact, but putting it in different framework. I think that kind of things happen in history of physics, like I think analytic mechanics and the use of group in the quantum mechanics and so on
I see.
In the 20th centuries. Do you think it's a kind of is this comparable to this kind of reconstruction of physics using the new techniques in the mathematics, or is it completely different?
Well, I think it's very important point. So here, in fact, I'm sorry. So here, in fact, I wrote that the special relativity is a historical example of this new paradigm emergence. But this special relativity actually replaces Newtonian mechanics in a certain way, but it keeps it to be correct in a certain regime of slow motion, right? So it's possible that this new realm, which I claim as AI physics, would be something really like that, yes. So it's an extension of the theory, a new interpretation, but it's not replacing the original. Yeah. Thanks. Other question from Professor Finkenthal or Professor Suzuki? Do you have? Please.
I don't have now a question because I will come back to some of those things. Can you put back the previous slide and leave it there for my talk also? The next one, after this one. Yeah, this one. I will use some of the things on this, so please leave it there.
Okay.
Okay, for me too.
Great.
Just one remark for the representative of philosophy. If I would have sitting there as representative of philosophy at the end of, after absorbing as much as I could from this view graph, I would have said, you say there philosophy not necessary? This whole thing is philosophy. The thing
right. Yes.
So it's a matter indeed. I will use several times the word semantics and semiology of what I will define as algorithmic thinking. And after I drop those words, you understand why I say that there is a lot of philosophy in all this. Philosophy cannot be discarded from the discussion.
Okay, thank you very much. Yes. Yeah, that's a very important point. So this, So why I said that the philosophy is not necessary is, I didn't mean it. This is ordinary science, which is defined by Thomas Kuhn. And philosophy is, of course, necessary at any occasion of physics revolution. But here, since current physics, which is based on quantum field theory, has no good unexplainables or some outer force which actually makes this paradigm shift. So in this sense, we are kind of doing just ordinary physics, ordinary science, which doesn't need a philosopher's viewpoint. Thank you very much.